All right, hey everyone. Section 8.4, day 2. So pretty much what we're going to do is we're going to continue what we were doing in the first part of section 8.4, but now we're going to be doing it with solving two triangles. Okay, so take a look at number 1. A pilot flying at an altitude of 2.7 kilometers sights two control towers up ahead. The angle of depression to the base of one tower is 37 degrees. The angle of depression to the base of the other tower is 58 degrees. What is the distance between the two towers? Round to the nearest tenth of a kilometer. So that's a lot of information going on, right? So pretty much what we have to do is we have to figure out what this picture looks like, right? And luckily on this one you were given a picture. So here's your plane, all right? And the plane is flying at this altitude of 2.7 kilometers, all right? So airplane up here, 2.7 for our altitude. That makes sense, okay? Well, the angle of depression from the plane to the base of one tower is 37 degrees. So we know that an angle of depression of 37 degrees goes to tower B. Okay? And then we have this angle of depression to the second tower, that's 58 degrees. And that's going to base A, or tower A. So you have to be careful because when the plane is flying here and it looks down just a little bit, it sees the farther out tower. It has to look down farther, so 58 degrees, to get to angle A, which is actually the one that's closer to it. So be careful of that because when we're drawing our own pictures, that's going to be really important. And if you notice in the picture, these angles are already flip-flopped. So 37 degrees here, 58 degrees here. That is because of parallel lines. And so because the lines are parallel, those alternate interior angles are congruent. Okay, so we are looking for the distance between the two towers. Well, here's tower A and here's tower B. So the distance between them is x. But if we look at those two triangles, x is not part of a right triangle. So what I'm going to do over here real quick, I'm going to go ahead and draw these triangles separately. So here's the first one. Here's my A, C, there's the plane up there. So this is to get to tower A. So that distance is y. And I've got a 58 degree angle. And I know that the height here is 2.7 kilometers. So that's the first triangle that I see in there. And then I have another right triangle, which is a bigger one. And here's my airplane. This is to go to tower B. So again, we know the height is 2.7 kilometers. This one, we know that the angle is actually 37 degrees. And this distance here they gave us was z. Which means looking at those two triangles, we can do exactly what we were doing yesterday, or today in class if you're watching this in class, and we can solve for y and z. But the problem is we want x. So you have to be able to look at this picture, and I'm sure you guys can, but you have to be able to look at this picture and recognize that z is equal to y plus x, right? The distance of y and x, if we add those together, we get to z, which means x is going to equal z minus y. So if I can find z and y and subtract them, I can get x, the distance I'm looking for. So that's all we're going to do, all right? So for this first triangle, let's grab another color here. For this first triangle, we've got our 58 degree angle here. And this 2.7 is our opposite, and y would be our adjacent. Okay, so let's go ahead and just solve for y first. So opposite and adjacent means tangent. So the tangent of 58 degrees is going to equal the opposite, which is 2.7 over the adjacent, which is y. So hopefully you guys agree with me, and y is equal to 2.7 over the tangent of 58. And normally I would tell you guys, hey, go ahead right away, put that in your calculators, right? But I have a feeling that's going to come out as a decimal, and I don't want to round until the very end. So I'm actually going to leave that alone. All right, I'm going to leave that as y. So it's 2.7 over the tangent of 58. That's my y value. And now I'm going to solve for z. So if we look over at the blue triangle, here's our angle of 37 degrees. The 2.7 is our opposite, and again our unknown is our adjacent, but now our adjacent is z because our angle is 37. So the tangent of 37 degrees is equal to the opposite, which is 2.7, over, whoops, equal sign, Miss J, over z, which means z is going to equal 2.7 over the tangent of 37. And again, I don't want to put that in the calculator quite yet. I'm just going to go ahead and box that because I know that that's my z value. I only want to round one time, so I don't want to put those in the calculator because then my rounding is going to be all sorts off. So we said that x is equal to z minus y, which means I'm just going to put those in the calculator. Here's z, right? So I'm going to go ahead and do 2.7 over the tangent of 37 degrees. Now notice I closed that parenthesis. I'm also going to move out of that fraction, okay? And then I'm going to subtract my y value. Well, here's my y value, 2.7 over the tangent of 58 degrees. And then I'm going to go ahead and hit enter. And I get 1.895, blah, blah, blah. So round to the nearest tenth of a kilometer, which means x is going to equal 1.9 kilometers. Okay, again, I didn't round until the very end, because if you round at each step, then you have a problem, right? So most of the time I'm going to ask you to hold off on rounding and putting stuff in the calculator until the very end. So hopefully you're okay with that. Hopefully you followed along. All right, question 2. So Isabella is relaxing on the back of a boat while her brother Alejandro is attached to a 400-foot rope parasailing behind the boat. When Isabella first starts recording a video of her brother, she sees him at an angle of elevation of 12 degrees. When she finishes recording, the angle of elevation is 37 degrees. How much higher did Alejandro rise during the video? And this time we went around to the nearest foot. Well, this time we also don't have a picture, right? So it's kind of a problem. We have to understand what's happening in this picture. So Alejandro is attached to a 400-foot rope and he's parasailing. So hopefully you guys know what parasailing is. It means that he's attached to the boat and he has a parachute on and he's kind of flying behind the boat. Essentially, that's my version of it, or my definition of it at least. So we're going to say, I'm going to say Isabella is over here on her boat. Okay? So this is Isabella. And when she first starts recording her brother, he's at an angle of elevation of 12 degrees, which means here's the water, right? Isabella's boat is on the water. And she's looking up at him at an angle of elevation of 12 degrees. Which means her brother starts out, and I drew this part a little bit too far, sorry, but her brother starts out at some distance right there. Okay? Well then, Isabella keeps going, and all of a sudden, or she keeps videoing, excuse me, and all of a sudden her brother's at an angle of elevation of 37 degrees. Which means the second time she measures his angle, he's gone higher. Okay, so we need to figure out how much higher did he rise during the video, which means we're looking for this orange piece, just the orange, because we're looking for how much higher he rose, which means he started out at some distance y, and he ended with some distance z, and we're looking for how much he grew. Ooh, you know what I forgot, you guys? I'm so sorry. our angle of elevation for the second one. That's our 37-degree angle. Okay. Now let's see if we can figure out what else we know. Alejandro is attached to a 400-foot rope. That means that here's the boat that Isabella is on. This is the rope that he's attached to, because Alejandro is here and here at his start and stop, which means this is our 400 feet of rope. So what I'm going to do really quick, I'm going to draw those two triangles separately so I can kind of see what's going on. So the first one, the rope is 400 feet, I know that for sure, and the angle of elevation is 12 degrees, and we're looking for Alejandro's height, y. And that's what he started at. Alright, and then for the second one, now we're looking at when he's higher. So that angle of elevation is 37 degrees. The rope is still 400 feet. And now he's at his total height, which is z. So again, we want to look at that and be able to say, okay, well, we're looking for x, right? Well, we know that z is equal to x plus y. But we're looking for x by itself, which means x is going to equal z minus y. Now in this case, I chose my labels so that it's the same equation as it was in number 1. If you chose different variables, that's okay. The point is that we're looking for this distance here. So whatever it was that you called it, that's fine. Could be a little different if you picked different variables from me. So now all you guys have to do is solve for y and z, and we're going to find the distance in between. So we've got an angle here, and we know that y is our opposite. 400 is our hypotenuse, which means opposite, hypotenuse, that's a sine function. So the sine of 12 degrees is going to equal y over 400. So y is going to equal 400 times the sine of 12. That's his starting height then. So whatever height he was at when she first started recording, it was 400 sine of 12. So we could get a decimal, but again, I don't want to round until the end. Then his final height, let's see if we can figure that out. So again, here's my 37, z is my opposite, 400 is my hypotenuse. That's another sine function. So the sine of 37 equals the opposite, which is z, over the hypotenuse, which is 400. Let's move that over so you can see, sorry. So if I move that 400 over, z is 400 sine of 37 degrees. Okay, and we know, again, that x is going to equal z minus y, which means in this case, x equals, well, z is 400 sine of 37 degrees minus y, which is 400 times the sine of 12 degrees. And we're going to put that in our calculators. So 400 sine of 37. Make sure you end the parentheses there. And then subtract 400 sine of 12. And we're rounding to the nearest tenth of a foot, so 157.6 feet. That's how high Alejandro rose from the time she started filming until the time she stopped filming. So again, the hardest part here is actually setting up that picture. And once you've set up the picture, you're good to go. You guys can solve these triangles. That I have no doubt about. It's definitely the picture that's going to be the hardest part for you. All right? We will do the next one actually together in class tomorrow. So I will see you guys later. Bye!